Hey Pallavi, how are you?
Good to see you, Steve.
Yeah.
I'm doing good.
A lot of news about AI at this show, and Nokia is all over AI itself with AI RAN. Why is that important?
So, first of all of the AI traffic is changing. Second of all, we are sitting at the cusp of physical AI. This is where the world is going to be about, AR, VR glasses, drones, robots, autonomous cars. And, for you to build the network for that physical AI to happen, it's no longer about keeping the network and the compute as two different things. I like to say that the network and compute are going to become very symbiotic. And to me, with those things staring right in front of us, it is time for this industry to innovate, and hence we are working on AI RAN.
So, in a sense, there are two different things and you're bringing them together. So you have AI, which is the application, the services, the inference and the training and all of those things, but then you have the traditional radio access network, and now you're integrating those two things in a seamless way.
Absolutely.
So instead of sort of having a hyperscaler carrier universe, we have a peaceable kingdom. Is that the idea? I mean, that seems like it's good news for carriers.
Yeah, I mean, just look at it. Let's look at a swarm of robots that are actually carrying a critical payload on top of it. And in this world, a 10 millisecond jitter is not like a bad pixelated movie experience, Steve.
Yeah.
A 10 millisecond jitter in this world is a critical safety incident. So, this is where we have to build networks that actually go about and make physical AI happen. Because, again, let's play out this whole example. The robot is going to do little bit of vision inferencing, but it needs to now have a model that actually helps it stabilize. But that model is big enough. Can you go to the cloud for every single decision? Where the environment is changing and we are constantly chasing photon to motion consistency. You just can't do it. It's simple laws of physics. You can try fighting it, but I can tell you can't beat it.
Yeah.
So you need to bring in distributed inferencing. The stabilization model has to run on a compute which is close to the robot. And in this case, why not then run it on the same compute that now runs your telco workload? And to me, as you start playing out examples of distributed inference, you start to see that, the network and the compute become symbiotic, and you start to blur the boundary and create a seamless AI grid.
Nokia itself is changing from a traditional telecom communications equipment provider from the last century, where everything was hardware, into almost like a hyperscaler, like a software distributed model. How do you reconcile that change with the culture of your traditional customers, which is carriers and tier one carriers around the world?
It gives us a unique advantage, having the assets all the way from radio to the cloud. Because, we're starting to talk about everything that you're talking about is not disruption that is just waiting to happen. If you look into the data center side of things, that disruption has already happened. From servers, it started to go to rack of servers. From rack of servers, then, it moved over to AI data centers, to now to AI factories. That's where scale up wasn't a concept 10 years back when, I was building up routers and switches. Scale up has just happened. After scale up, now we are talking about scale out. After scale out, we are now talking about scale across. All of the requirements of low nodal latency, lossless, is becoming even more important.
So let me ask you a question, because obviously AI traffic itself presents carriers with a challenge. I mean, it's not just a sort of half duplex model, down but not up. Now it's across, and agentic talks to each other the whole time.
This is one of the biggest reasons why we are building AI RAN. Because traditionally what you've seen is, I like to call that networks have been built for busy hour traffic. You go about and over provision the network, looking at, what's going to be your peak workload, and you then go about and build networks basis of that. But with the amount of traffic that we are talking about, with the amount of burstiness we are talking about, with the dynamism between uplink and downlink, you cannot just go about and build networks the same way as we have been building. which is where fundamentally what you have to do is you now have to make some of these protocols, some of the RAN functions like beamforming, channel estimation, scheduling, that have been done, the same way like 30 years back. You now need to make them intelligent, and that is what I mean by AI native networks. Bringing in, AI models and then bring it with closed loop automation, so that, classic example is beamforming. Rather than do it traditionally where you go about and send 100 probes, can we now have AI models using Bayesian optimization go about and get you intelligent probes?
Thank you so much.
Thanks,
It's
Steve.
always a pleasure. Thank you.
Thank you.